Dear students, welcome to eShikshana program. In today's class, I will be discussing on predictor and corrector methods, which are nothing but multi-step methods. In particular, I will be considering two methods prescribed in your syllabus: Milne's predictor corrector method and Adam-Bashforth predictor corrector method. So in these methods, multi-step methods, unlike the previous methods which depends only on the previous value, these methods depend on sequence of previous values to compute the next value. So these methods are prescribed in the syllabus to solve first order ordinary differential equation of the form dy by dx is equal to f of x comma y with given initial condition y is y naught at x is equal to x naught. Suppose the solution of this equation is known at four successive points: x naught, x1 that is x naught plus h, x2 that is x1 plus h, x3 that is x2 plus h, where h is this terminal. Let y naught, y at x is equal to x naught, y1, y at x is equal to x1, y2, y at x is equal to x2, and y3, y at x is equal to x3 be the known solutions. Known, that is it depends on the previous values, that's what it says. Suppose we wish to find or determine the solution at x4, the next value of x, x4, after x3, x4, that is x3 plus h, that is equidistant values of x. That is y4, finding y at x equal to x4. We apply the following two methods to find y4, namely Milne's method or Milne's predictor corrector method and Adam-Bashforth method or Adam-Bashforth predictor corrector method. So these two methods are nothing but the single multi-step method, whereas the three methods which we discussed in the earlier classes, Taylor series method, modified Euler's method, and Runge-Kutta method of fourth order, or in general Runge-Kutta method, are the single step methods. So let me consider one by one. First I will consider Milne's predictor corrector method and then Adam-Bashforth predictor corrector method. In these methods, we predict the value of y and then using the predictor formula and then correct it or refine the value of y obtained from prediction using the corrector formula. But let me consider Milne's method. First multi-step method, Milne's predictor corrector method, or simply Milne's method, predictor corrector method. Milne's predictor corrector method. So first we predict the value, that is Milne's predictor formula. Milne's predictor formula. Okay. Corrector method. Used to solve differential equation of the form. Consider dy by dx is equal to f of x comma y with given initial condition y at x is equal to x naught, y naught. Okay. So Milne, if the values are not given, the successive value, previous values, that can be obtained by the single step methods. Okay. Milne's predictor formula. Milne's predictor formula. Milnes predictor formula. And this is given by Y4P. Y4P. So P stands for prediction. Y4P is equal to Y0 plus 4 into H divided by 3 into 2F1 2 into F1 minus F2 plus 2 into F2. Okay. So after predicting the value, we refine it or correct it using Milnes corrector formula. Milnes corrector formula. And this is given by Y4C. So C stands for correction. Corrector formula Y4C is equal to Y2 plus H by 3 into F2 plus 4 into F3 plus F4P where F4P is F of X4 comma Y4, where F4P is F of X4 comma Y4P, and F1, F2, F3 are all. F1 is F of X1 comma Y1, and F2 is F of X2 comma Y2. F3 is F of X3 comma Y. Now let me apply this Milnes method to solve first order ordinary differential equation. Now let me consider problem on this. Problem 1. Given dy by dx is equal to x minus y square. Given dy by dx is equal to x minus y square with condition sequence of values y at x is equal to 0 is 0, y at x is equal to 0.2, 0.02, y at x is equal to 0.4 is 0.0795, 0.0795. Y at 0.6 is equal to 0.1762. So these are the sequence of values which required to find the value at 0.8. Compute net value of x is 0.8. Compute y at x is equal to 0.8 by applying Milnes predictor character method. Predictor character method. Predictor character method. Okay. So here the question is find the value of y at x is equal to 0.2. So making use of the four values of x, x0 at x1, x2 and x3. Okay, so first let us write down the given data. As I told you, it is always good to write the given data so that you will know what exactly you have to do. So given f of x comma y, f of x comma y is equal to x minus y square. Okay. Then x naught is 0. Corresponding value of y, that is y naught, is also 0. X naught is 0, y naught is also 0. Next value of x1, x1 is 0.2. So this is 0.2 and corresponding value of y1 is given to be 0.0. This is your y. Next, y2, x2 is 0.4. The corresponding value of y2 is 0.0795. Then x3 is the next value 0.6. Corresponding value y3 is 0.1762. 0.1762. Then x4 is 0.8. This is the next value of x, 0.8. And we have to find out this value y4, that is the value of y at x is equal to 0.8 using Milnes predictor corrector method or simply Milnes method. So Milnes method means by default it is Milnes predictor and corrector method in your course. Okay. Now let me what is h here? You take any difference, x4 minus x3 is h, equidistant values of x. So h is 0.2. So h is 0.2. Now let me read out the data here. So f of x comma y is f of xy is x minus y squared. X minus y squared. Then x naught is 0. Corresponding value y naught is also 0 in this case. x1 is 0.2. Corresponding value of y, that is y1, 0.0. Next, x2 is 0.4. Corresponding value of y, that is y2, 0.0795. Then x3 is 0.6. The corresponding value y3 is 0.1762. 0.1762. Then x4 is 0.8 and we have to calculate this value using Milnes predictor corrector method. So h is 0.2. I have mentioned here h is 0.2. Take any difference. Anyway, x2 minus x1 0.2, x3 minus x2 0.2. So equidistant values of x. Okay, let us apply the predictor corrector formula to compute y4. Milnes predictor formula. Milnes predictor formula. Milnes predictor formula. Okay. It is given by y4p. P stands for prediction. Predictor formula is equal to y naught plus 4 into h divided by 3 into 2 into F1 minus F2 plus 2 into F3. 2 into F3. Okay. So let me calculate these functional values at x1, y1, x2, y2, x3, y3 and substitute here to compute to predict the value of y at x is equal to 0.8. Okay. So f1 is f of x1 comma y. f1 is f of x1 comma y1. So this is equal to f of, what is x1 here? 0.2 comma y1 0.0. Apply the definition of f of x comma y. X minus y square, that is 0.2 minus 0.02 square. 0.2 minus 0.02 square, and this is equal to 0.1996. So this is 0.1996. Okay. Otherwise, let me write here 0.1996. That means f1 is 0.1996. Similarly, f2, f of x2 comma y2, x2 comma y2. So this is 0.4 comma 0.0795. So by definition, this is 0.4, that is x minus y square, 0.4 minus 0.0795 square, 0.0795 square, and this is equal to, if you compute carefully using calculator, you get 0.3936. 0.3936. Okay. Then F3, similarly, F3 is f of x3 comma y3. x3 comma y3. This is equal to f of 0.6 comma 0.1762. So, when I apply the definition, you get 0.6 minus 0.1762 whole square. So, if you compute this carefully using the calculator, you get 0.5689. 0.5689. Okay. Now substitute all these values. All this as substitute in 1. Substitute in the values of f1, f2, f3 in 1. Substitute the values of f1, f2 and f3 in 1. f3 in the Milner's predictor formula to predict the value of y at x is equal to 0.8. So y4p is equal to y0 is 0 plus 4 into h, 4 into 0.2 divided by 3 into 2 into f1. f1 is 0.1996 minus f2 is 0.3936 plus 2 into f3 is 0.5673. 0.5688. So if you compute this carefully, carefully, you will get F4P is equal to 0.304. So compare this, you get 0.3049, that is Y4P. Now we shall correct this using corrector formula. So Milnes corrector formula. Milnes corrector. Milnes corrector formula, that is given by Y4C. Y4C is equal to Y2 plus H by 3 plus H by 3 F2 plus 4F3 plus 4F3 plus F4P plus F4P, call this as equation number 2. F4P. Okay. So F2 and F3 we already calculated. F1 is point F2 already obtained 0.3936 and F3 is 0.5689 0.5689. Okay. Then I have to compute F4P now. F4P, let me compute. See, this I know by the previous value. F3 also I know. F4P I have to calculate. F4P by definition is F of X4 comma Y4P. X4 comma Y4P. This is equal to F of X4 is 0.8 comma F4P is 0.3049. 0.3049. So by definition, this is 0.8 minus 0.3049 square. And if you compute this carefully, you get F4P is equal to 0.7070. 0.7070 up to 4 decimal places. Okay. Now substitute n to obtain F4C. Substitute n to substitute in this relation through. So again Y4C is equal to Y2 is 0.0795 plus H by 3, H is 0.2 divided by 3 into F2 is 0.3936 plus 4 into F3. So 4 into F3. F3 is 0.5689. Then plus F4P. F4P is 0.7070. 0.707. So if you carefully compute this using your calculator, you will get 0.3046. 0.3046. 0.3046. Okay. This is the corrected value, but this can be refined by subjecting it to iterations. Then let me call this as the first iteration. First iteration. First iteration. Let y4p is equal to this corrected value 0.3046. 0.3046. So calculate F4P. Calculate F4P. So F4P is F of X4 comma Y4P. X4 comma Y4P. So this is equal to F of 0.8. F4P is this F4P. 0.3046. So apply the definition. 0.8 minus 0.3046 square, and it is 65. If you calculate, you get 0.7072. 0.7072. Okay. Now, substitute in 2 again. Substitute in 2. So from 2, substitute in 2. So 2 implies from 2, so let me write like this. That means what we are doing here, we are substituting this F4P here and calculating Y2 4C. So from 2, Y4C. From 2, Y4C is equal to, everything said, you see, 0.0795 plus 0.2 divided by 3, 0.3936 plus 4 into 0.5689 plus F4P, this value 0.7072. Close the bracket. So, if you carefully calculate using calculator, this will give you 0.3045. 0.3045. So next, let us compare this value obtained in the first iteration with this value. Up to 4 decimal places, if they coincide, we shall stop the iteration process and conclude that value of y at x is equal to x4 is 0.3046. So there is a difference in the last digit, last decimal place. So we have to again refine it. So that, let me call this as second iteration. Let F4P is equal to, you take this as F4P, 3045. So F4P is everything same. I'll just change here only, but this is the procedure. 0.3045, and if you apply the definition, 0.8 minus 0.3045 whole square. So this F4P is 0.7072 again. 0.7072 again. So you get again 0.3045. 0.7072, the same thing will come here. So from 2 again, from 2 you get 0.3045. So our first iteration was also 0.3045. Second iteration is also 0.3045. Since the first iterated value and second iterated value are the same up to the 4 decimals, we conclude that value of y at x is equal to 0.8, that is x4 is equal to 0.8 is 0.3045. So we can conclude that sets the first and the sense you can sense the first and the second iterations are the same. Iterations are the same up to 4 decimal places while 4 is equal to while at x is equal to x4, that is point A is equal to 0.304. So the value of y at x is equal to point A by Milne's predictor corrector method is 0.3045. 0.3045. So let me consider another example. Example number 2. Example number 2. Example number 2. From the data given below, find at x is equal to 1.4 using Milne's predictor corrector method. Milne's predictor corrector method. dy by dx, the differential equation is dy by dx is equal to x square plus y divided by 2. X is equal to 1. X is equal to values of x, values of y. 1 corresponding value of y is 2. 1.1, 2.2156, 2156, 1.2, 2.46, 2.4649, 1.3, 2.7514, 7514. Okay. So I need to calculate the value of y by the known values of the previous values of x at x is equal to 1.4. So let me write the data, rewrite this data as per our convenience. Okay. So given f of x comma y is x square plus y by 2. Given f of x comma y is equal to x square plus y by x square plus y by x square plus y by. Okay. Then what else is given here? So x naught, this is your x naught, x1, x2 and x3. So x naught is given to be 1, corresponding value of y naught is 2. Then next value x1 is 1.1, corresponding value of y is 2.2156. Then x2 is 1.2, x2 is 1.2, corresponding value of y, that is y2, 2.4649. The next value of x3, 1.3, corresponding value of y, that is y3, 2.7514. 2.7514. Okay. Then I need to calculate x4 is 1.4. 1.4. I need to calculate y4 at x is equal to, that is y at x is equal to 1.4 using Milne's predictor and corrector method. Okay, so let me write the data which is very much required. Okay. So given f of x comma y is equal to x square plus y divided by 2. X naught is given to be 1. Corresponding y naught is 2. x1 is 1.1. Corresponding value of y1 2.2156. x2 is 1.2. Corresponding value of y, that is y2, 2.4649. x3 is 1.3. Corresponding value of y, 2.7514. 2.7514. And x4, next value of x is x4. x4 is 1.4. So this value we have to find using Milne's predictor corrector method. Okay, this is the data. Okay, let me apply predictor formula to predict the value of y at x is equal to 1.4 first. Milne's predictor formula. Now this formula you have to remember. This is given by y4p. P stands for predictor. Predicting the value of y is equal to y naught plus 4 into h divided by 3 into 2 into f1 minus f2 plus 2 into f2 Okay. So where f1 is f of x1 comma y1 is equal to f of x1 comma y1 1.1 comma 2.2156. So this is equal to, by definition, x square 1.1 square plus y by 2 2.2156 divided by 2. So this is equal to, if you carefully calculate, this is 2.3178. 2.3178. Okay. Now similarly, f2 is f of x2 comma y2. So this is equal to f of x2 is 1.2. x2 is 1.2 comma y2 2.4649. So by definition, this is 1.2 square plus y by 2, 2.4649 divided by 2. So if you compute carefully using your calculator, F2 turns out to be 2.6724. 2.6724. 2.6724. 6724. Okay. Now I need one more quantity. That is f of 3. F3 is f of x3 comma y3. So this is equal to f of 1.3. What is your h here? H is 0.1. H is 0.1. Okay. H is 1.3 comma y3 2.7514. 2.7514, and using the definition, so this is 1.3 square plus 2.7514 divided by 2. So if you calculate using calculator, you get F3 is equal to 3.0657. 3.0657. Okay. Let me substitute all these values of f's in 1. Substitute the values, the functional values, the values of f1, f2 and f3 in 1. So y4p is equal to y0 is 2 plus 4 into h is 0.1 divided by 3 into 2 times f1. So 2 into f1 is 2.3178 minus f2 is 2.6724 plus 2 into f3 is 3.0657. 2 into 3.0657. So if you compute carefully, f4p will be, if you compute carefully, f4p will be equal to 3.0792. 3.0792. So this is your predicted value. Now let us refine this value by using Milne's character formula. Milne's character formula. Milne's character formula. So let me call this as, so this starts from y4c. Y4c is equal to y2 h by 3. There is no 4 here. H by 3 into f2 plus 4f3 plus 4f3 plus f4p. You call this as equation number, where okay, f4p is f of x4 comma y4p. So I know what is f2 and f3. Only thing y4p I have to calculate. So I will just list what is f2. F2 is 2.6724. Then f3 is 3.0657. Now I have to calculate f4p. I know the definition of F4P. F4P is f of x4 comma y4. Y4P is this 3.0792. So this is f of x4. x4 is 1.4. y4p is 3.079. Okay. After the definition, so this is x square 1.4 square plus 3.0792 divided by 2. And if you carefully compute this, calculate this value, your F4C will be 3.4996. 3.4996. Let us use in 2 to obtain Y4C. So from the equation 2, Y4C is equal to Y2. Y2 is 2.4649 plus h by 3. H is 0.1 divided by 3 into F2. F2 is 2.6724 plus 4 into F3 plus 4 into F3 is 3.0657 plus F4P is 3.4996. 3.496. Okay, 3.4996. Now if you calculate using your calculator, student calculator, so you will get Y4C is equal to 3.0793. Okay, 3.0793. Okay. Let us refine this first iteration. First iteration. So here, let us assume that Y4P is equal to 3.079. Now you compute F4P. So therefore, F4P is equal to f of x4 comma y4p. So if you substitute the value, x4 is 1.4, y4p is this 3.0793. 3.0793. So if you use the definition, this is 1.4 whole square plus y by 2, 3.0793 divided by 2. So if you calculate this one, F4P will be 3.4996. 3.4996. So from 2, substitute the value of Y4P from 2 here. So everything same is here. Here Y4P is 3.4996. Here also Y4P is 3.414996. You can easily make out. So therefore, from 2 you get the same value 3.0996. 3.0973. Okay. So from 2, okay, I will write here. Okay. Okay. So from the equation 2, y4c is equal to y2. y2 is 2.4649 plus h by 3.1 by 3 into f2. f2 is 2.6724 plus 4 into f3 3.0657 plus f4p. f4p is 3.4996. Okay, so if you compute, these two are same exactly here. 2.4649, 0.1 by 3, 2.6724 plus 4 into 3.0657 plus 3.4996. So if you compute, you will get back, you get the value 3.0793. 3.0793. So since F4C and the first iterated value are the same up to 4 decimal places, we can conclude that the value of y at x is equal to 1.4 is 3.0793. So you can conclude like this. Since first iterated value that is this value, and y4c that is this value, y4c are the same up to 4 decimal places while 4, that is y at x is equal to x4, that is y at x is equal to 1.4 is equal to 3.0793. So I got the value 3.0793. 079. Okay. Okay, so this is how we go through to solve the first order differential equation with a sequence of values of previous values, sequence of values of y for the previous values of x by the method of Vinay's predictor-corrector method. So in my next class, I will come up with few more examples on Vinay's predictor-corrector method, and then I will discuss Adam-Bashmore predictor-corrector method. Okay. Thank you.